Problem 35 is where we start to look at what are called antiderivatives, or they're also called indefinite integrals. What this means is that we go backwards. Basically, we have a derivative and we want to know what the original function would have to be. This is what problem 35 is asking for. It reads, find the function with the given derivative whose graph passes through the point P. Well, we're given the derivative. We're given f prime of x equals 1 over 4x to the 3/4. Let's rewrite this as 1/4 times x to the negative 3/4. Let's think about this for a moment. We know that normally when we have x to an exponent, for example, if we have f of x equals x cubed, we find the derivative by multiplying in front by the exponent and then subtracting 1 from the exponent. That's how we go from original function to the derivative. Then to go backwards, we need to add 1 to the exponent. We also need to deal with this number up front. And the way we do that is we multiply by reciprocal of the new exponent. For example, if we were just given f prime of x equals 3 times x squared, then to go backwards, we add 1 to the exponent, so it becomes x cubed. We also multiply by the reciprocal of this new exponent, which is the cube, giving us an original function of x cubed. These are the two steps you need to, there we go. These are the two steps you need to have to undo the power rule of derivatives. Okay, well, let's apply this then to the function we were given. If we're given that the derivative is 1/4 x to the negative 3/4, then the original function must be x to the positive 1/4, because negative 3/4 plus 1 is positive 1/4. We also need to multiply in front by the reciprocal of that new exponent. So our original function is x to the 1/4. We can always check this by taking the derivative. We find that f prime of x is 1/4 x to the negative 3/4, which equals 1 over 4x to the 3/4. And that is, in fact, what we started with. Okay. There is a reason why they gave us this point P. The reason is because of this. I need to make some more space here. Let's say that instead, again, we're going to a hypothetical. Let's say I started with x cubed plus 10. Well, I know the derivative would be 3x squared, and that if I was to go backwards, though, I would find just x cubed. Well, what happened to that plus 10? The problem is that whenever we take a derivative, the constant disappears. So if you were finding an antiderivative or an indefinite integral, you need to know one of the points it passes through in order to come up with that constant term. So the original function is x to the 1/4 plus c. We then use the point 1, negative 2 to find out what that constant term c is. Say negative 2 equals 1 to the 1/4 plus c. C equals negative 3.